Okay, so previous slide was just introduction to various scheduling technique and then the importance of scheduling. And then now we are going to zoom in bit by bit into network technique, but by introducing the terminology with regard to the critical path and whatnot. Okay, then only our next slide we will go into AOA diagram, and then the following slide will be on AON and precedent diagram. But before that, we do have another slide with regard to WBS in order to complete the whole concept first. Okay. Okay, you by now you already know about the history. Gantt chart was being developed way back in 1910, and then late 1950s come the AOA diagram, and then PERT diagram was being developed in the middle of 1960s, and then late 1960s the AON and then PDM diagram was being introduced. Okay, that was history. Advantages of a network diagram, basically for the purpose of showing the critical path. Okay, now later on, we are going to introduce the concept of critical, wait a second, critical path. Okay, critical path. Okay, what is critical path and what are the critical activities, why they are so important in the network diagram. Okay, what is the purpose, right? Effective resource planning. Okay, we are going to introduce a bit, okay, because you will learn this thing in second half of the semester. And then the issue of cost, again, is part of the second semester topic. And then the EOT, delays. Again, this is the second semester topic, which I'm not going to cover, okay? Rescheduling is much easier if using software. Yes. The purpose of we using the software is for the tracking purposes. Tracking is more difficult than developing the planning itself. It is even to develop a planning, if you are not well experienced, you might find it very difficult. But then it is not as difficult as doing the tracking and monitoring. That is the most critical part, because you need to have some kind of creativity, how to catch up with the work diagram, work program, etc. Okay, critical path method, CPM. Is the critical path method is the what we call the calculation method, actually calculation method, in order to identify which is the critical path, and at the end of the day we are going to know the project duration. Project duration is being generated based on critical path. Okay, critical path is the longest duration in the network diagram. Okay, later on we are going to take a look at what does that mean by the name of path itself. Okay, two variation. We can use AOA diagram, and then we can use AON diagram to show in terms of graphic. So I would say this diagram, okay, this diagram is basically the graphic way to represent the scheduling, whereas the CPM is the calculation method. Calculation method. Calculation method to identify the critical paths and critical activities. Okay. All right. Advantages, disadvantages, and then you see the diagram can be applied AOA or even PDM diagram. Advantages is for the sake of once we connect those activities together, then we are going to know or understand the impact of each activity when one activity is being delayed or basically take longer time to complete. Okay, that is the purpose. The main purpose is just to understand the impact. Once we understand the impact, then we can take action. action in terms of how do we recover the time that we already lost. Example, during the COVID situation, we in Malaysia last time, we stopped everything. We stopped the economic activities. I think for maybe for a few weeks, then only we realized that stopping the activity will not solve the problem. See, at one time we very proud that we already have zero COVID cases, but we never know because COVID could be coming from outside of Malaysia. People sometimes come into Malaysia during illegal path, you know. They can come at using not through the immigration, but there are so many ways to get into Malaysia. That is the issue. And then to identify the critical path, critical activity, why? Example, let's say if we do know that the two activity, let's say activity D and E, one is critical and one is non-critical, not critical. Let's say both activity require what we call crane, mobile crane. And those activity could be a little bit far from each other. Whereas when you use mobile crane, that mobile crane have to move into that position and then to basically lock the position in order to do the works. It will take quite some time in order to crane to move and then set at that particular area and then be moved to another place. So if you identify one activity D is critical, whereas E is not critical, what does that thing mean? That simply means you must give priority to activity D compared to activity E with regard to utilization of crane. Because both activity require crane, maybe at the same time, but because you only have one crane, you do not want to rent another crane, which will increase your cost. So you use that crane for activity which is in the critical situation, whereas another activity which is not considered as critical, which that activity can be delayed a little bit within the allowable time frame. It is not to say you push that activity E to certain time frame where you will delay the overall project. No, no, no. We just simply say if that activity do have some kind of free time, why don't we utilize that free time so that our priority can be given to activity which we define as critical activity. And critical activity, it is not that activity, it does not simply mean the activity is important, whereas another activity is not important. No, 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 no. That is not by definition. You must remember that all activity are important. Otherwise, they won't be needed in order to construct a building. Anyway, you need all activity are needed. But then, in terms of the so-called the timing, this is what we call we can define the activity by either it is critical or non-critical. That is why we do use this concept, critical path method. Okay, but disadvantages, if you do not learn, if you do not have any knowledge, so that is what we are doing in this class. We try to give you knowledge. If you already have some kind of knowledge, it is good. Okay, perhaps you can score A plus in this class. But if you do not know, don't worry. We are going to go bit by bit from zero knowledge that you have about critical path method, and I can assure you at the end of the day, you should be able to develop a network diagram, including all the calculation, and then later on, you should be able to identify the critical path, critical activities, and whatnot, okay, related to those things. Okay, so this is example of arrow diagram and PDM diagram. You see, you notice that arrow diagram, the way to draw those things is we draw using the node. You see the node, and then this is what we call another node. Node number 2, node number 1, and then the activity is A. Okay, so the duration we normally put it here, and you notice that inside those cycle, this is just one way of drawing. You can draw in many different ways. For instance, I would like to draw something like this. A using node, and then you see node 2. This is what we call early start, early finish, late start, late finish. You notice all this terminology here is inside those what we call node, and those terminology, basically this terminology refer to critical path method terminology. So we want to understand those terminology first, then later on you can easily calculate and put all the numbering into those circle or even the box. So this is ADM diagram. And how about PDM diagram? PDM diagram, an activity is being shown in a box because activity or node activity is inside the box. But inside the box, we do have compartment, we do have space to basically put our early start, early finish, late start, and late finish. And then we do have what we call total float, and then duration. Everything is inside a box. Okay, so the difference between activity A and then activity B, A here, the way it will reflect according to the graphic that you choose. If you choose PDM, this is the graphic. If you choose AOA diagram, this is the graphic. But in terms of terminology, they are all the same. Okay, they cannot be different. At the end of the day, when you draw using AOA diagram and then PDM diagram, you should get the same result, except that the graphic would be different. Avoiding terminology confusion. Okay, if you are still learning from fresh, then you will not get any confusion. But if you have been working, or let's say you have been learning about this so-called CPM diagram for many years, if you learn from old people, they would basically say, okay, AOA diagram is equivalent to CPM. So the old people will basically relate AOA diagram as CPM. Well, in reality, CPM is just the method of calculation, whereas AOA and PDM diagram use the critical path in order to calculate. Okay, so remember, AOA diagram and PDM diagram is just the graphic representation of a network, whereas critical path method is the method of calculation you can apply in AOA or even in PDM diagram. All right, so don't get confused. Okay, activity on arrow. How to draw again? So you start with node. See the nodes. The node, you can name the node by node number 1 and then close with node number 2. And then top here you write down the activity A, the proper name. And then at the bottom here you put duration. So this represent one activity A. And then if you do have another activity, you will repeat the same process. You already have the closing node 2. And then what you need to do is just draw an arrow, close with arrowhead, and then close with one node. Let's say node number 3. And then you will name that thing activity B. And then at the bottom of the node, you write down the duration. So this diagram reflect activity on arrow. It has two activity A and activity B. Okay. So again, if you connect those activity together, A, B, D, E, until the end of activity, it will basically reflect the network. It is not the straight line. The network meaning to say, you will draw something like this, okay? And then something like this. So you might have activity, see? And then another activity, then another activity, then another activity going into this one. You see, all interconnecting. You start with one so-called node, and then close with one node. That's what we call network diagram. Oftentimes, when people draw the network diagram, there are some activity which is not connected to certain activity. That is not a good way of drawing. Good way of drawing, all the activities should be interconnected. Okay, interconnected. Like something like this arrow diagram. This is nice arrow diagram. You see, one node started with one node here, and then ending with the last node. This should be the right network diagram. And you notice that there are so many activities, A, B, C until H. And at the bottom of each arrow indicate the duration of each activity. And you notice that there is numbering inside those nodes. This is what we call the CPM calculation. We are going to go into this thing, but I can just simply go through very quickly, very simple. We start with 0, okay? 0, you plus with 2, equivalent to 2. See? 2 plus with 3, equivalent to 5. 5 plus 4, equivalent to 9. 9 plus 2, equivalent to 11. But wait a second, because there are two arrows going into this one. You need to do the calculation from the C. Okay, again, 2 plus 2 here, equivalent to 4. 4 plus 3, equivalent to 7. 7 plus 3, equivalent to 10. You notice that 9 plus 2, equivalent to 11. So between 10 and 11, the bigger number will go into this one. 11 plus 1, equivalent to 12. You see, this is what we call project duration. Now, you see, you notice that you already answered the question when the project is going to be completed. It is at 12 days, 12 working days. We do not put the holiday yet. This is just solid working days. Okay, 12. And inside our diagram, if you start from this node until the end of the node, you notice that there is a two path. One is here, see, this path, and the bottom one is what we call another second path, two paths. So this is what we call path, P-A-T-H. So inside this drawing, there are two paths. If the question asks you, how many paths in this network diagram? So how to identify those paths, P-A-T-H, is from the beginning of the node until the end. You will see the interconnection, and there are two paths. But between these two paths, what can be considered as a critical path? You notice that if, for instance, you take the first path, let's say path number 1, and then this is path number 2. If you add all the duration of activity together, 2 plus 3 plus 4 plus 2 plus 1, it is also equivalent to 12 days. Whereas when you add the bottom path, path number 2, 2 plus 2 plus 3 plus 3 plus 1, which is equivalent to path number 2 equivalent to 10. So critical paths basically reflect the longest path. This is what we call critical path. And then this critical path will automatically indicate the project duration. So meaning to say, we cannot complete a project if you are given 10 days. 10 days is meant to complete path number 2 only. Meaning to say, activity in the path number 2. But activity in the path number 1 require longer time by 2 more days. By 2 more days. Okay, so that's why we cannot complete a project in 10 days. We need 12 days in order to complete all the paths, including the longest duration of activity in path number 1. So that's how the project duration normally being linked together with the longest path in the network. Okay, later on, we are going to further what we call define what could be the critical activities. Okay. All right. Activity on node. As I mentioned, activity on node. Okay. Activity on node. You start by drawing a box. We call it box. Previously, remember the word node normally come in a circle because AOA diagram was invented first, late 1950s. Then only in the late of what we call 1960s, they invented AON diagram. AON diagram. The word node is still maintained there, but then in order not to get confused with AOA diagram, so the node now is being, even a long time ago, being changed into the what we call the square. So that's how we differentiate between AOA diagram and then AON diagram or even PDM diagram. So whatever it is, the square indicate, the left side is indicate start, and then the right side indicate finish. Start, finish. It repeat after itself, finish. The arrow just indicate relationship between activity A and activity B. What is the relationship between activity A and B? The relationship is taken after this wording. Finish this to start, FS. When activity A start, finish, then immediately activity B will start. But remember, in the actual construction, let's say activity A is 5 days. 5 days. So we will start in the first day, but in the calculation, we put 0. We do not put 1 because if you add 1 with 5, it becomes 6, which is inaccurate in terms of calculation. When we calculate, we start with 0. 0 plus 5 equal to 5. Let's say activity B is 6 days. And then immediately after A completed, we will start in immediately 5 plus 6 equivalent to 6 days. So if you add 5 plus 6, which is equivalent to 11, meaning to say both activity will be completed in 11 days. But bear in mind, activity A will start on the first day and then will finish at the end of day number 5. Activity B, it will not start at the end of day number 5. It will start on the following day because at the end of day 5, which is not working day anymore, because at 5 p.m. everybody is going back already. So you cannot start the work during that day. You must follow the actual working time, which is next day. That's how, in reality, thing is being what we call equate, or people understand that way. Okay, but in terms of calculation, we do something like this. Okay, this is the example of PDM or AON diagram. Okay, AON diagram. But we call it PDM because it has something extra. We have not learned that PDM diagram yet, but I just want to show the relationship between PDM and then AOA diagram. You see, inside this box, I would call this thing as early start, early finish, late start, late finish. We have not defined the word early start, early finish, late start, and late finish yet. Don't worry. We will go into that after this. And this is what we call duration. This is what we call total float. So at the end of, after we learn this thing, you should be able to do the same calculation. Okay, how do we do the calculation? Remember, A reflect an activity. The calculation is within the box, within this box. 0 plus 2 equivalent to 2. You see? Because at the end of second day, activity A will complete because it is only 2 days. And then immediately B will start. So this value will be transferred to 2. 2 plus 2 equivalent to 4. And then You notice that here, this means lag, lag equivalent to 1. We do not learn that thing yet, but never mind. Later on, okay, let's start with D first. You notice that lag is 1 day. What does lag mean? Activity A and D, by right, it should start at the same time, but lag means delay. We delay the starting of the following activity by 1 day. So, activity D do not start on 0, it will start on 1. 1 plus 1 equivalent to 2. 2 then transfer here. 2 plus 1 equivalent to 3. And you notice that this one is 3 coming from 3. And this one is 4 plus 1, meaning to say it will start at 5. So the 5 now will be the starting point for C. 5 plus 1 equal to 6. You notice that when we do have lag and lag here, it will basically reflect the calculation. The calculation will be according to whatever what we call the detail that we want our scheduling will look like. What is the purpose of lag? Sometimes in construction, we do have curing. You know, curing for concrete, we need to wait for the concrete to dry up. So that's why you just simply cannot do the construction when the concrete is wet, especially doing the floor. When you just concreting the floor, and then after that you will need to erect the column. You cannot work on the wet concrete. You need to wait. So that waiting period could be what we call could be equate to lag, meaning to say you delay a little bit the starting of the following activity. We will cover those things later on, but I just want to show you the differences between the calculation of arrow diagram and then a PDM diagram. Okay. Basic component of network diagram, we must have activities or namely tasks, logical relationship, arrow, node, and then critical path. Okay. Activity we already mentioned. It is the breaking up of the component of major activity so that we can measure the quantity being done in order to what we call calculate the progress of work. If we do not break up into smaller activity, then it is very difficult. Okay, example of activity A, C, D. This is what we call activities inside the network diagram. Start is what we call milestone. Milestone is the important event. Okay, it doesn't have any duration. It just want to show you, oh, this is the start of a project. Okay, it has 0 duration. Type of activity. If we are talking about major work program, the activity name could basically, we can just simply put a big activity: production, procurement, management activity, milestone, dummy. Dummy is another thing that we are going to discuss later on. Example, this is major name of the major work program. But if we want to detail out, then the name will be reflected for the sake of what kind of work that we want to associate with. Okay, WBS. We do have slide for WBS later on, but just this slide is just still introduction to the whole thing that we are going to go through. WBS can be divided into responsibility, structural element, location, category of work by people, equipment, and then payment purposes. This is what we call BQ. Okay, normally in Malaysia, we do have JKR, Public Work Department. Sometimes they wanted the scheduling to be reflective of the BQ in the contract document for the sake of tracking the payment purposes. So that's why sometimes we split the activity according to the BQ, which is inside the contract document. Okay, so WBS looks like the organizational chart. Okay, but organizational chart is for the people. WBS is for the work, the breakdown of the work. Okay, so you have one project name, whatever name, and then you break up into major activity, and then you break up into smaller activity. Okay, example, the WBS normally do have what we call level 1, level 2, level 3, and could be level 4 and whatnot. You can split into smaller sub activities, but you have to be very careful when you split into smaller and smaller activity meaning to say could be very detailed. When you have too many detailing, you sometimes you will kill yourself, especially when you want to do tracking. So you need to have all kind of information in order to input into your computer, whereas you might not have time to input all the detail. That's why sometimes people just simply abandon the project schedule that they did because they found it to be very difficult to update the project. At the end of the day, they just simply use the Excel, go back to the basic, okay? Because the issue of too much detailing. You do not want to kill yourself. Okay, let's take a look at this simple project, garage. Even a small garage, you can split into a few major work: foundation, structural, roof, floor, and wall, external work. Then you split it further. See, even foundation, you can split into many sub-activities. External work also you can. This is how you split into a few levels. Okay, later on I will show you how to use Microsoft Project. Then perhaps you will appreciate the concept of level 1, 2, 3, and etc. Okay, then dependency, logical relationship between activity. You notice there is activity A and then activity B. Okay, so the relationship is basically finish to start relationship. But then there are certain activities when you start activity A, then finish, then you leave a gap. This is what we call a gap before starting of activity B. That gap is what we call lag or delay. You delay a little bit the starting of B. You do not want to have activity B start immediately. Example of the gap is basically, as I mentioned, is the curing. Curing is not an activity by itself. It just simply you want to show in a project scheduling that waiting period. You must wait 1 or 2 days in order to allow concrete to dry up, and then only you will start another subsequent activities. So that is what we call logical relationship between activities. Okay, this is an example. Type of relationship. I already mentioned about the first activity, finish to start, which is the most common type of relationship found either in AOA or AON diagram. But remember, AOA diagram was developed using this activity and this type of relationship, finish to start only. And then subsequently, when they develop AON diagram also use this type of relationship. But then when PDM diagram came, then we do have this kind of relationship to be put into the network diagram, which make that PDM diagram, I would say, more complicated. Okay, but more complicated in such a way it is manageable. It is not something that people simply cannot understand totally. Once you learn this thing, very quickly you can understand the whole concept. Okay, finish to start relationship. So remember, start, finish, at the end of the box, start, finish. So that's why this relationship is being called finish to start, because the arrow is coming out from where? If the arrow is coming up from the right, meaning to say it come up from the finish and then enter into B at the left side of the box, it indicates start. So that's why the type of relationship we call it finish to start. Then start to start. Start to start. Remember, maybe the first activity is A. So the arrow is coming from the left side. This is the left side, start. Then goes into B and then close by arrowhead. By right, we should have arrowhead. That should be the accurate way of drawing. You see, this one is also start. That's why this relationship called start to start. In the context of drawing where to put B, you can put B anywhere in your drawing, but the most important thing is where the arrow is coming out and goes into. That is the most important thing. Otherwise, people will not understand what type of relationship that you are trying to show to them. And then finish to finish. Okay, finish to finish is the contrast of start to start. Start to start meaning to say both activities start at the same time. And then in terms of finishing, we don't care. Maybe A will finish first and then B will finish a little bit later, or the other way around. It depends on how long it will take to complete those tasks. But in the case of finish to finish, the starting is not that important. The important is basically the finish. How to draw those things, you see, start, finish. So the arrow is coming out from the finish and then goes into B at the end, at the back of the arrow. So that's why this one, we call it finish to finish relationship. We don't care about the starting of A and B. The most important thing, we want them to finish at the same time. Maybe we do have one activity called C to be connected to this type of relationship, so that both activities should be completed at the same time, especially when we are dealing with activities such as cut and fill. Normally, when we do cut and fill, they are running concurrently at the same time. Okay, both activities must be completed in order for subsequent activity to start. And then start to finish. Start to finish is in contrast of finish to start. Okay, later on, I do have another slide. When, let's say, A wanted to start, B must be completed. Okay, B could be completed. Example of such relationship. Let's say we do have a bridge, we do have an old bridge, and then we are constructing a new bridge. Okay, for sure, among the activities, it involves we need to demolish the old bridge. When exactly we can start the demolition of the old bridge? We can only start to demolish the old bridge when the new bridge is completed. You see, that is example of start to finish relationship. We start demolition of old bridge when the new bridge is basically finished in terms of construction. Otherwise, how exactly people is going to use the bridge? Because we do not completed the new bridge yet. Because people are still using the old bridge every day. Okay, then logical relationship again. I just want to show you this. When you look at this diagram, automatically you understand when there is a node and then there is arrow going into the node, this must be arrow diagram. Okay, arrow diagram. Okay, the one that I want to reflect is basically how to read activity, let's say activity C. How do you read activity C? If you find something like this diagram, activity C can only start when A and B completed. Let's say A completed in 5 days, B completed in 10 days. So when can C begin? C can only start taking after the longest duration between A and B. Even though A can be completed in 5 days, but then activity B will take longer. So C don't have any choice. C will only can start the project after 10 days when B completed, and then C can start the work. So what does this concept simply tell us? This thing simply tell us that A basically have some free time equivalent to 5 days. So if we want to delay activity A, the maximum time that we can delay activity A, or we can delay the starting of activity A, or even maybe A will take a longer period. Instead of 5 days, it will take 7 days. So we can still finish the project according to what we already planned, because A simply have 5 days free time that he basically can play around. Maybe A initially we plan to put 2 workers. We can just simply use 1 workers. It will take longer time, but that longer time still within the manageable period. So this is what scheduling is all about. Why we need to know all those calculations? Because we can play around with the resources. If we can play around with resources, then perhaps we can cut down on the cost of resources. Okay. All right. Now dummy activities. Dummy activities. Okay. Dummy activities. Dummy activities is normally being put into arrow diagram. Most of the time being put in arrow diagram. Okay, arrow diagram. It is not necessary to be put in PDM diagram, because PDM diagram already has sufficient type of relationship that can reflect all those things. Okay, because arrow diagram only use, remember, finish to start relationship, and sometimes when you draw the diagram, it can be very messy. It can be in such a way the line could be tangling around. You do not want that thing to happen. It is very difficult to read the diagram. So you put the dummy activity. And dummy activity is being denoted by the dotted line. You see, you notice dotted line. It is not a thick line, dotted line. When you see a dotted line in an arrow diagram, so automatically you will know that they are dummy activities. They do not have any duration, 0 duration, compared to A, B, C, D. A, B, C, D do have a duration, okay? But how do we read this dummy activity? Let's say we start with activity C, How to read this thing? Let's say if we do not have the dummy activity, let's erase those dummy activity. How do we read C? C can only start after A completed. That's it. That's how we read activity C without the dummy activity. But when we draw dummy activity using this kind of arrow, and you must always remember the arrowhead, the direction of arrowhead also reflect the right relationship, or the relationship. So you must be able to identify where does the arrowhead going backward, forward, whatever. Okay, so if the dummy looks like that, being drawn in upward position here, the way we read C, meaning to say C can only start when A and B completed. You see, by having a dummy activity, it basically will reflect totally a different way of reading the relationship, because dummy activity reflect relationship. Okay, but how about D? Let's say we do have dummy, something like that. How do we read D? D will only start after B completed. It has nothing to do with the dummy activity, because the arrowhead do not pointed toward the so-called D. It pointed towards C. So activity D has nothing to do with A. But if, for instance, we draw the dotted line the other way around like this, you see, then the way we read is that activity D will start after A and B completed. You see, so that's why I say dummy activity is needed in order to complete our drawing, especially in arrow diagram, because in some situation the diagram could be very packed, okay, and we want to reflect the right relationship. So that's why we introduce the word dummy activity. And basically it is nothing wrong with the drawing. When we do have dummy activity, it basically enhances the drawing anyway. Okay, duration. There are two duration here. One is for activity duration, one is for project duration. Project duration meaning to say at the end of the network diagram, the last values that you will put into those diagram, these indicate the project duration. Whereas the activity duration belong to each of the activities. Okay, how do we calculate activity duration? So first, relying on past experience. That's why I say to you, when we want to develop a project scheduling, you need to have knowledge. You need to have skill. Okay, skill normally based on work experience. You do not acquire skill by reading books. No, you do not. You have to do it. Doing it is basically getting the hands-on experience, real construction site. And then arithmetic computation. Yeah, you need to do calculation by using standard guide. The issue with standard guide, we in Malaysia, there is so far none of any books or publication related to I would say productivity. I call it productivity rate with regard to construction works. This rate normally being kept secret by the contractor especially, or whatever organization, for the sake of for themselves only. They do not share. And if you get that productivity rate also, well, you can use that for the purpose of developing the scheduling. But in reality, the productivity rate have to reflect your real work or real output capacity. Different organization do have different work output capacity, because it is based on the skill of the workers, the type of the equipment, and then the tool that you use, and many different factors. Okay, so meaning to say productivity for each organization might be different. So that's why different organizations do keep the data for themselves. But in US, mean standard, you can take a look at this guideline, mean standard, MEAN, do publish about productivity, but that productivity belongs to the country. Well, everybody can have some kind of reference. Again, you need to modify according to your real work. Okay, this is just example. Maybe this is, we will stop at the end of this slide. We have not finished this slide yet. We will continue next week, don't worry. I just want to give you example, okay? How to calculate the duration for each activity, okay? Let's take a look at one simple activity that you want to do. Transporting extra or excess material outside of the construction work project. Okay, let's say you already done cut and fill, and then you already done your what we call leveling, sloping, etc., etc., then you have excess material. That excess material, you cannot basically leave it there at your construction site. You need to transport and put into a different place, allowable place. Let's say the place is located 24 kilometers away from your current site. Okay, you need to figure out what are the equipment, the machine that you need to bring these the excess material, earth. Let's say you need a lorry or dumper, and then you also need an excavator in order to put the soil into your lorry or dumper. Then you have output capacity of the machinery in terms of, let's say, if that machine, that lorry is traveling on empty, so it can travel faster, and then it will travel a little bit slow. If it is full, then it will take around 1.5 minutes in order to empty those what we call bucket of the lorry. And then how about this excavator? Excavator basically in order to scoop the soil and then put into the lorry. So the capacity is basically 40 cubic meter in 1 hour. Okay, that is basically output capacity. All of the machinery, when the manufacturer develop the machine, they do have this output capacity. You can go into a maybe website of Caterpillar. Caterpillar is one of the top or CAT, top equipment manufacturer. They do have manual output capacity for every of their what we call machine. And with regard to all the data about that machinery, let's say how long, let's say if you are using in whatever gear, how fast can that machine move, what could be the carrying capacity, output capacity, everything. Okay, so each of the manufacturers should have the data. Okay, now this is what we call resources. Resources. Okay, lorry can carry 220 cubic meter in 2 hours. Where do we get 2 hours? Okay, based on this data. 30 minutes to fill in, 59 minutes to transport, about 1.5 minutes to empty, and then to return is about half an hour. When you add those things together, it will be 120 minutes. It is like 2 hours. And the lorry capacity is only 20 cubic meter. So meaning to say, if a lorry wanted to carry the excess soil 24 kilometer away, one trip go and back from the place will take around 120 minutes or 2 hours, and the capacity is only 20 cubic meter. And in one day, remember, one day the working hours is 8 hours. So meaning to say, 20 times 4 trip equivalent to 80 cubic meter per day. Whereas, remember, how much soil that we need to carry? 800 cubic meter. So meaning to say, if we want to complete this job in one day, we need to have 10 lorry. See, 10 lorry, because one lorry only can carry 80 cubic meter, can do the job 80 cubic meter per day. So if we want to complete that during one day, you see, one day, then we need 10 lorry. The issue is that, do we have that many resources? If you do not have that resources, then you can play around with the duration. You lengthy the duration, but then you less number of resources. For instance, 5 days, then you need 2 lorry. But if you only have 1 lorry, then basically you need to work for 10 days. That is the relationship between resources and number of days. Remember, the duration of activity is, we need to calculate. It is not based on just simply putting whatever the number. No, that is wrong. We calculate based on productivity calculation. Okay, let's say the first estimate, 10 lorry for 1 day. And then how about excavator? Okay, remember excavator capacity can scoop 40 cubic meter per hour. So 1 day we do have 8 hours of working. So just imagine 40 times 8 equivalent to 320. 320 divided by number of volume of work, then we have three numbers. Okay, three numbers. So the conclusion is that if, for instance, we want to complete the project in 1 day, then we need to have 10 lorries, and then this is what we call excavator. Excavator. You see how resources are being tied together with the duration. So this is what we call calculation method. All of the activity should be calculated using similar concept. The concept is coming from productivity rate. Okay, let me give you example of productivity rate again. Okay, okay, let's use this empty space. Okay, productivity. Productivity is equivalent to output per input. Output is what we call quantity divided by time. Time is the input. Let's say one painter wanted to paint the wall. Maybe he can do 10 square meter in 1 hour. This is what we call productivity rate. And then, what is the volume of work that he need to complete? Let's say we do have quantity of the wall 1,000 square meter. The question is that how much time required? Okay, how much time required to complete the work?